I'm here to represent me and my co-authors for this paper we produced in July, Who Wins Ethereum Block Building Auctions and Why? My co-author including Burak from TU Munich and Toma from Ethereum Foundation. I'm a data scientist at Flashbots. So this is the most common charts everyone looks at in the space, who is either a block builder or a relevant party like a relay runner or like even I think validators and staking services. So you quickly notice that this is the market share of all the block builders on Ethereum on a time series on a daily basis. And you would wonder, like here, it's basically two builders nowadays are building block builders, Ethereum blocks. Over 80% are built by Beaver and Titan, the two entities. There were kind of like an evolution when Flashbots launched Mev Boost as an open source software. In the very beginning, Flashbots started by examples and we started building, and there's many more people adopted it. But quickly, there are some very competitive parties joined, including Beaver joining quickly after the 3 months. And there were rsync, who was very dominant for a while. Titan then later joined 1 year after, and now it's become just two people in the game. So then you would wonder, like, why? Like, we're talking about like and doing so much work to decentralize the validator sets, but like block builder side is very centralized. And one thing to point out as well is that yesterday from the audience, someone was saying like, so why basically all the block builders, top block builders are making most of the MEV. I think that might be a misconcept. When you look at this chart, it's a little bit tricky. It's because the people who have the most market share is not necessarily having the highest profit, right? So we also have to like look at a different dimension. When you look at this chart, which is representing all the block builders' profits on the y-axis, and the x-axis is the profit margin, which is defined by basically for the blocks you build, how much you were able to keep as your profit divided by the total block value. You would see that, sure, the top 3 block builders are also represented as the biggest bubble. The bubble size is by market share, are generally the most profitable, and they are also like generally having a positive profit margin. But also there are some party who are like having really high profit, but they have really small market share. That means like they don't really build blocks or win blocks often, but when they do, they win a lot of profits. And there are also people who like, we don't know what they're doing here. It's like they have actually a relatively good market share, but they are subsidizing the whole time. So later, once we dig into all this data, we realize, for example, this builder himself is actually a solver on 1inch Fusion. And the whole reason why they are building blocks is because they want to subsidize to make sure they land their orders. So there's a lot of like micro behavior that's very interesting. And what we want to like establish it in like a more formal way rather than just, anecdotal secrets that we know from the industry. So yeah, we have to model this whole thing. There are a few things to mention here. First of all, one thing that's not in the slides is that when we talk about the MEV value here, what are we talking about? So if you think the MEV industry or like thing as a supply chain, right? The value flows from the user side, goes into the wallets, applications, the transaction sent into the mempool or private mempool through an RPC endpoint, and then it goes through the builders. The builders are listening to the public mempool and potentially having some endpoints that's receiving people's transactions. Not only user can send transaction to builder, searcher who are potentially monitoring the public mempool, seeing what are the price movements going to be from users' orders, might also add transactions before and after, send a bundle to the builder. And then here, builder will collect a list of transactions that they can consider for building the next block. And then they will then participate in an auction, which is a block auction. So they will send the bids to a party called Relay, supposedly a neutral party that's just basically like validating, checking if the block syntax is valid, and they will pass the bid towards all the validators. But one thing to note here, which was mentioned from yesterday, PBS or proposal builder separation, is that when the relay exposes the bid to the validator can only see the value and the block hash, which supposedly no information, what's the block content, what are the transactions in it. So now the validator or proposer really is just like, say, proposing, okay, I'm gonna take this block. And a rational player assumption is that they will take the highest value one. And so here, what I described is like what happens in a 12-second slot. Ethereum lands every new block every 12-second slot. if the slot is not missed. So you would think basically, okay, starting from the beginning, when last block is already landed, pretty much most of the high value transactions in mempool are cleared out, they're landed on chain. Now you're starting to like receiving or accumulating more and more transactions over every second. And at some point before the final, deadline, the block builder will try to like bid their highest value block. Or, I mean, some block builders who are not that sophisticated will keep bidding whatever they have in hand. And so you would see this block builder bids will go up like this, going up every second. And in the end, at +10 is when the final attestation deadline, if the block is not proposed, then it's going to be missed. So this is the process we need to model. And the third thing is that one thing we need to mention is like the block size is limited. So the block space is limited, then the block builder will not always be able to include all the transactions that they see, right? Because so that they would need to consider like the highest value transaction. And the value comes from basically the either priority gas fee or it's coming from some kind of like transfer to the builder address. We call it builder tip, which is basically like a Coinbase.transfer function in MapBoost as a feature. And so then you would want to know like, okay, what type of transaction have the highest value? There are sandwiches, there are NFT mints, or like retail users swapping on DEX. There are searchers doing SexDex, ARB. There are like ETH transfer that's probably not urgent. That's gonna probably pay low value. There's also liquidation. So to analyze all this, we built a taxonomy to try to put a label on all the Ethereum transactions. We have two dimensions. The first one is if it's a public signal or exclusive signal. Exclusive here doesn't really mean exclusive. It just means that it's a private transaction that was in a probably propagated through private channels that was never seen in a aggregated list of public mempool. And we listed the OFA bundles. It's kind of slightly tricky in the middle because OFA bundle somewhat is a user transaction that's shared partially privately to some searchers, and then searchers submit a bundle privately. But that's like a really small amount of transactions anyway. Another dimension is the order flow label. So basically like, is this transaction a MEV? Is this transaction a Telegram bot flow? Which for people who are not familiar with, Telegram bot is some type of like degen app where you go to Telegram bot, or you go to Telegram, you subscribe to a bot, you send money to them, and they will like keep like sniping tokens or like swapping like meme coins for you. Usually they're probably like high values because a lot of time those tokens are very volatile. People are trying to like snipe it before it goes up, etc. If it's a solver model, meaning like 1H CalSwap, Uniswap X, they are different from the traditional DEX trades because how the transactions are submitted. Because the transactions from the solver models are not really submitted by the user in their wallet interface through a RPC they decide, but instead are submitted by either the projects or the solver. So here, the solvers who are likely a more educated partner, they will choose to either pick a private mempool or potentially even go through OFA, etc. So if it's a SEX transaction, that means if someone is like a Coinbase user and I'm going to deposit some money to my like MetaMask wallet, and this likely with like intuitively it shouldn't be very like high value, but it turns out actually a lot of the centralized exchange, they are not very optimized in terms of the fee they are paying. So it's not like a negligible amount actually. There are swap flow, there is a OFA bundle, there's other types. We just generally categorize them into public or exclusive. So here are some results. So to list the major strategies we identify from the top block builders, here are a few things that they're doing to try to win the block or try to make profit. First thing is packing the block is pretty important. Like how you are merging all the transactions into a block matters to the value of the block, because oftentimes if you are like putting some transaction like you're like the way you organize the sequence, how people accessing liquidity in the pool can either make the transaction succeed and allow some searcher extract a large amount of value, or it may revert all the transactions, then you can only get gas fee. And it's probably not a good outcome. One interesting thing here we see is that in this chart, the pink part is the, top of block we identify or we define, which means the top 10 percentile by the transaction index out of all the transaction in the block, you could see it's interesting that top 10 percentile is making up more than like 70% of the MEV value out of the total block value for most of the top builders. Something also interesting is that a lot of the top builders like Titan and Penguin, they're experimenting something called like end of block searching. Or I guess I'm like giving out the answers, but really like you see some end of block value that's pretty significant for those builders, which is when you examine their blocks, there are actually searchers doing background arbitrage at the end of the block. We also see like people are subsidizing so to win market share so that they can basically promote themselves in the charts, and so then more people are gonna send them flow. We also see that like exclusive order flow, meaning basically high percentage of private order flow, is very important to also market share and profits. Of course, you can always increase your bidding frequency and improve your latency of the infra, and like bid with potential cancellations when you see you actually can bid slightly lower when you get extra signal. Some other correlation results is that we identify that the order flow diversity is also important to highly positively correlated to the market share. We identified that the order flow exclusivity is also positively correlated to the profitability of builder. This is when we especially see some long tail searcher builder who just want to search and lend their bundles will build a block out of like 9 transactions. And when they win, they're super high profitable. That's what we saw in the first chart. We also concluded that like there's an overlap of all these factors that contributes to also market share and also profits, including top of block and like atomic arbitrage and like other MEV types and Telegram bots.
Thank you so much, Danning.
Thanks.
Thank you.